Hello chemistry students, I'm going to go over the M1L2 notes here, and that would be properties of matter. Please note the slide number down here in the bottom right hand corner to help you navigate. Alright, so matter is anything that has a mass and has a volume. Volume means that it takes up space. Alright, so mass measured with the balance, volume, length, width, height, takes up or occupies space. Right. So mass is a way we measure the amount of matter, and we've already talked about volume there. Alright, so which of these things would be classified as matter? Well, let's go through them and talk about them. So nitrogen is a gas. It could fill up a balloon, so it takes up space. It may not have a lot of mass, but it does have a little bit. And if you don't believe that gases have mass, like air is also matter, just stick your arm out the window when you're driving, or maybe riding in a car or bus or something, and you should feel that you're having to push the air out of the way in order for your arm to go through it. So that's kind of an indication, hey, air does have mass. Water is also matter. It has mass and it has volume. Light and heat, those two, they're energy. They don't take up space and they don't have mass. Okay, the most common states of matter that we will talk about in this chemistry class are solid, liquid, and gas. So let's take a closer look at those. Alright, so solids have a definite shape and volume. So the particles in a solid are going to be packed tightly together, usually in an organized manner. Solids are usually dense, especially compared to gases. They're not easily compressed, or they're incompressible, and they do not flow. So here's a looks like a diagram of some water molecules, and you can see that they kind of have this crystalline arrangement, and you might notice that ice, frozen water, comes in cubes. It's a solid. Okay, liquids. Liquids have a definite volume, but they do not have a definite shape. And so they take on the shape of the container, which they fill from the bottom up. They do not expand to fill the container like gases do. So you can see the different liquids occupying the different shapes of these containers here. Liquids are going to have a similar density to solids, and they are fluids. They can flow. Alright, gases don't have any definite shape or volume. The particles in a gas move very quickly, somewhere in the order of 700 miles per hour on average at room temperature, or 340 meters per second. They fill whatever container they're in. They'll expand to fill the container, and they have the ability to flow. They are fluids, and they have very low density compared to solids and liquids. Alright, let's talk about atoms. So atoms are the smallest unit of an element that still have the properties of that element. So that's, you've probably heard this before, the building block of all matter. Alright, elements only contain one type of atom. So you're not going to be able to separate an element into a simpler substance under normal conditions. Now the condition where you could do that is maybe in a nuclear reactor, but we're not going to split a whole lot of atoms in chemistry class. Alright, so there's about 90 naturally occurring ones and some others that are artificially produced. You can find a list of the elements on, yep, you guessed it, the periodic table. Now there are some elements that exist as molecules, like O2 and N2 or S8, but they're still elements because they still only have one kind of atom in them, even if they have multiples of that atom in their molecules. Here's the periodic table. There's your list of all the elements. And there's a lot of stuff here. You know, we go all the way up to number 112 on this particular periodic table. So sometimes a little bit of study is merited if you're trying to figure out if something's an element or a compound. So like if you're looking for iron, for example, you might look for I and be like, oh my gosh, there's iodine. Where's iron at? And then you realize, hey, it's over here and it's Fe. And maybe we'll talk about why that is when we name compounds later on. All right, so compounds. Compounds are going to have the smallest unit being a molecule. And in the molecules of a compound, there will be at least two different elements. So like, for example, here's the water molecule, and it's got two hydrogen atoms chemically bonded to one oxygen atom. So if these are all oxygen atoms, this would be ozone, and it would be an element. But since it's two different elements or atoms of two different elements bonded together, that makes it a compound. All right, pure substances, that is a category that describes both elements and compounds, and it essentially contains only one type of matter. So you could have a tank of oxygen, O2 gas, or you could have a block of dry ice, which is carbon dioxide. That's a compound. Okay, it will have a chemical formula. That is the key thing for identifying a pure substance, is that you can write a definite chemical formula for the substance, and that will be the same everywhere. Another example is water, H2O, two hydrogens to one oxygen, always. All right, here's another one, sugar, copper, and let's just throw out here, this has a chemical formula, so it's a compound. This is a single element. It's a so it is an element or single type of atom. Maybe helium, that would be an element in the balloons, and then water is a compound because it's H2O. All right, so for classifying here, matter can be divided here. We got pure substances. Now we're going to fill in on the other side over here. That's going to be mixtures. All right, so mixtures contain a blend, a physical blend, so there's no chemical reaction taking place here, of two or more substances. That means that they don't have a definite composition. They don't have a chemical formula. They have a variable composition. For example, when you maybe brew tea, you may like to add more sugar to it or less sugar. And if you go to different restaurants, you'll notice that the composition of sweet tea is quite variable. Some places have a lot of sugar mixed in, some places have less sugar mixed in. Water is a compound, sugar is a compound, and when you mix them together, they don't chemically react, they just blend with each other. All right, so those mixtures are going to be able to be separated by physical processes. An example would be filtering to separate one thing out of the mixture. You'd have to have a very a filter of very small pore sizes to filter out sugar, but it could be done with like a reverse osmosis process. All right, so some examples of mixtures: air, even pure air. It's a mixture of gases, right? Because it's got nitrogen and oxygen and carbon dioxide and water vapor and a bunch of other trace gases. A forest, mixture of a lot of things there, trees and animals and soil and rocks. And beef stew, definitely see the chunks of different things in the beef stew. And gold jewelry, unless it's 24 karat, is a mixture as well. Like if you get 10 karat gold, the gold has been mixed with another metal or possibly more than one metal to make it more resistant to dents and scratches and deformation. 24 karat pure gold is really too soft to make jewelry that you would wear on a daily basis. All right, so matter, two types, pure substance, mixtures. We're going to subdivide those as well. All right, so heterogeneous mixtures don't have a uniform composition. In other words, you can kind of see the individual pieces or chunks of the mixture. So you'd have two or more groups or two or more phases. So tossed salad, milk from the cow because the fatty part of the mixture, the cream, separates out. Right, and then a homogeneous mixture has a uniform composition throughout. So you're not going to be able to see two groups or two different phases. It'll look like it's the same substance all the way throughout. So salt water, if you haven't mixed up thoroughly, it should look that way. Kool-Aid, gold jewelry, you shouldn't see where you shouldn't be able to differentiate the different substances within a homogeneous mixture. All right, so classifying here, pure substances, those are the elements and the compounds. Mixtures can be heterogeneous or homogeneous. And there's another thing that's kind of between heterogeneous and homogeneous because its particle size is not big enough to really see them with the naked eye, but they do have some unique properties, and that's a colloid. So particles don't settle out, but it does scatter light. So colloids have a cloudy appearance to them. Things like milk, fog, those are going to be colloids, and if you shine a beam of light through them, you'll see the beam of light being reflected off of the particles. This glass here probably has a drop of milk or something in it, so you can see it's the milk water mixture is scattering light from the laser beam. All right, so classify these. Pause for a second, try it, and then unpause and check yourself. All right, so feel free to contact me if you have any questions about any of these. All right, so we're going to go on and talk about physical and chemical properties. So physical properties are going to be able to be observed without changing the identity of a substance. So changes in state, color, size, melting point, boiling point, solubility, and density are all examples of physical properties. Okay, so the physical change is going to change the substance without changing its composition. And that means that the physical properties, what the substance is, will stay the same, even though something about it physically changes. Sometimes those can be easily undone. Here's some examples: cut, bend, change phases, dissolve. The easiest to undo is to change phases because you can just raise or lower the temperature to cause a phase change. All right, so here's some examples of phase changes with cutting and melting. All right, extensive properties depend on the amount of matter present. So the more of the matter, the more of the property. Mass and volume are examples of this, but an intensive property does not depend on the amount of the substance present. So density and color those would be examples of properties that don't depend on how much of the substance you have. All right, so chemical properties explain how something changes into a new substance. So an example would be flammability. We have a whole page in the reference table that's devoted to chemical reactions and how things change into new substances or chemical properties. All right, so in a chemical change, a new substance or more than one new substance is created. So you start with one substance, it's a reactant, and then you make a new substance that's a product. So burning, respiration, digestion, rusting, and even baking a cake can result in chemical changes. All right, so there you go. Baking bread, rusting, respiration, digestion, burning. Burning is a great example of chemical changes. So here's your rule of thumb. If a precipitate, gas, energy change, or a surprising color change happens, then a chemical change has probably taken place. By the way, this is formation of a precipitate here, and also you see the color change, gas being produced, or if it gets hotter, color.